So next concept is arrangement of n distinct objects into R different groups. Okay, so in the previous case you had studied distribution of n distinct objects into R different groups. So what is different here? The difference here is the word arrangement. Can somebody explain me what is happening when I'm saying I'm arranging these n objects into R different groups? Yes, Gayatri. Now the order will be important within the group. See, let's say I say there are two boxes, box 1 and box 2. Okay, box 1 and box 2. Let's say I am distributing the 4 distinct objects O1, O2, O3 and O4 into this. So when you distribute O1, O2 like this and O3, O2, O4 like this, it is same as if you are distributing O2, O1 and O4, O3. That means order of these objects within the boxes are not important to us. You're just distributing. You're not worried about arranging them within the box itself. So they are said to be same distribution. They are said to be same distribution. But these two are said to be different arrangements. So these two distributions are same distributions, but they are different. Let me write it down here. But they are different arrangements. Please get this right. But they are different arrangements. Are you getting my point? Okay. So now I don't want to give you the direct formula. I want you to think. I don't want to kill your innovative instincts of problem solving. Tell me, in how many ways can I distribute? Sorry, not distribute, arrange. That's the word. Sorry for using the word distribute. By mistake, it comes out of my mouth because I've talked so much about it. So let's say these are your R different boxes or distinct boxes. And let's say these are your N distinct objects. Okay, they're all distinct objects. In how many ways can you arrange these objects into these R different boxes such that blank box is allowed or blank group is allowed? How will you solve this question? Not at all, Madhav. It's not going to be complex at all. Arrangement case, trust me, they're easier than distribution cases. Yes. Anybody has an idea? See, a simpler way to accomplish this is, let us take these balls and let's allow them to intra-arrange. Okay, how many ways can these balls intra-arrange? How many ways can these n balls be ordered among themselves? You will say n factorial ways, correct? Isn't it? N objects, how many ways can you order them among themselves? N factorial ways. Absolutely, Madhav. Okay. Now what I will do, I will treat these boxes to be like partitions. So I have to create R partitions. Correct? Yes or no? Can I say to create R partitions, I would need R minus 1 separators, or you can say sticks. Correct? So what I'll do is, I will take these sticks and I will mix up with these balls and I will try to shuffle them. Okay. So see again, try to understand. Imagine it in your mind. That will be more helpful for you to understand this. You have these n distinct balls. Take R minus 1 identical sticks. Okay. So take R minus 1 identical sticks. Okay, identical sticks. Now I'll say, why identical, sir? Our boxes were distinct. No, it is not because boxes are distinct I have chosen it to be identical. See, it is because the moment I place a stick anywhere, automatically it will group those number of objects trapped between any two. For example, let us say I mix them. I mix this. Okay, so let's say I have these and I just try to shuffle it. Okay, so let's say after shuffling I realize the position is this: O2, O1 stick, O3, O8, O, let's say 17 stick, O11. I'm just taking some cases. Okay, now when let's say this kind of shuffling has happened, automatically this is like segregating these objects into groups, and it also takes care of the order because you're shuffling the entire thing. So this combination will be considered to be different had this O1 been before O2 and there was a stick over here, and let's say others remained the same. Are you getting my point? Okay, so this would be a different arrangement. Now see, what I'm trying to say here is, when you place a stick over here, this automatically becomes group 1 or box 1. This automatically becomes your item in box 1. Okay, this automatically becomes your item in box 2. And you know one thing, when two sticks come next to each other means box 3 is empty, box 3 is blank, and so on and so forth. Are you getting my rationale? So I'm creating an analogous situation. So again, I'm repeating what I'm trying to do here. I take the n balls, which are all distinct. I take R minus 1 sticks, which are all identical, and I mix them. Mix. Okay. So the ball and the stick mixing that has happened will automatically decide, first of all, their segregation. That means they will be automatically decided in segregated into R different groups. And secondly, when I'm shuffling them, the order of the ball, if it changes for the same stick position, will create different ordering of the object also. Right? So what we call in Hindi, ek teer se do shikar, correct? So with one act, I accomplished both the things. So having said so, what is my final answer then? So the final answer to this is the same answer that you would get when you have n distinct objects plus R minus 1 identical objects arranged among themselves. So how many ways can you arrange? Let's say it is like asking you the question, how many 4-letter words can you make from moon? Where M, N are distinct and O identical. Your answer will be 4 factorial by 2 factorial, isn't it? In the same way, here the answer would become N plus R minus 1 factorial by R minus 1 factorial. This is the answer. Please make a note of it. Please make a note of this. This is going to be your answer. Absolutely, Madhav. Is the rationale clear, guys? What was my logic? That is clear. That is more important. Don't remember formula. Your formulas are ephemeral. How come the two cases are so different? Why they should be same? Many people think, sir, getting arrangement is like multiplying factorial with a combination. Okay, that is fine when your things are very simple. But things become complicated. They will have a different shape and sizes and form altogether when they are complicated. Okay. All right. I'll give you one opportunity to think this out from scratch, just like I thought this out from scratch. If your blank groups are not allowed, how will you do this? How many ways can you arrange? The word here is arrange n distinct objects into R distinct groups when your blank group is not allowed. Let me see who is able to think. Wow, Hariharan has already cracked it. Gap method, absolutely. Go ahead. By the way, this is a hint also for everybody. Gap method should be used. So how to use gap method? Please try this out. Yes, Madhav, that's why the gap method. Now, two sticks are not allowed next to each other. Absolutely, Madhav. So what I'm going to do is I'm going to just give you a hint here. In fact, I'll solve it also, don't worry. Okay. And you can only place your sticks in these gaps. Not before also, not after also, because if you place it before means the first group is blank. Yes. What's the answer? Let's see who is able to crack this. Come on, HSR and YPR. Other groups have cracked this question. Absolutely. See, first of all, these balls can be intra-arranged in n factorial ways. So you can shuffle them in n factorial ways. Correct? No problem with that. Now, when it comes to placing the sticks, when it comes to placing these sticks so as to create the groups, you have n minus 1 gaps. So these crosses, there will be n minus 1 crosses. Correct? And out of that, I have to choose any r minus 1 gap so as to put my sticks. That's it. This into this will be your answer. Okay. Minor change, Madhav. It is n minus 1 cr minus 1 because sticks are identical. You can't shuffle them. Right? Shuffling of sticks is not going to be helpful. So don't use p with the sticks. So all you need to do is choose those r minus 1 gaps and drop the 1 stick there over. Groups are created. Isn't it? Aditya also same thing. Got the point here, everybody? Okay. So these are the two takeaways from it. Let's take some questions. Guys, this may be on a slightly complicated side, but this can be solved if you are able to think through this. All right, let's have this question. Very easy question. How many ways can 5 different balls be arranged? Now watch out for the word used in the question. Arranged into 3 different boxes so that no box remains empty. Done? Simple. No box remains empty means blank groups are not allowed. So what is the answer? N factorial n minus 1 cr minus 1, right? So 5 factorial into 4c2. Correct? So it's 120 into 6, 720 ways. Is that clear? Any questions, any concerns here, please do highlight. Okay, all right. Now, with this, we move on to the next case.